Welcome students, welcome to the class 10th, and as you all know that we are in the midst of pandemic, and that is the reason we are all locked down at our homes. So we'll be studying a new way. Well, actually it's not that new, but kind of a new for us, and we'll be studying it through online video tutorials. So without wasting any time, let's begin with our very first tutorial of a computer class, Introduction to Object Oriented Programming Concept. So let's see the topic for today's session. Number 1, object-oriented programming. Number 2, the difference between OOPS and procedure-oriented programming. Number 3, OOPS concept, and the 4 principles of OOPS, that is inheritance, abstraction, polymorphism, and encapsulation. Now, the first thing, what is an object-oriented programming? When an object-oriented programming, it is a concept, or you can say it is a methodology or a paradigm to design a program using classes and objects. Yes, these are the two important keywords over here, classes and objects. Number 1 is objects. First we will discuss object and then we will discuss classes. Now, what do we mean by an object? So let's see the definition. An object is a real world entity which possesses an identity. It has some properties and some behavior. Whereas a class is a group of objects, or we can say a blueprint from which these objects, they are grouped together into one single class, and all these objects share some common properties and behavior. So let's take an example. We have a class dog. Now in this class dog we have 4 objects, 4 different kinds of dogs over here. Now these are objects. The class is dog, and all the dogs in the class dog is an object. Now all these objects, they share some common properties like breed, size, age, color, and they share some common behavior such as they eat, sleep, they run, and they bark. Yes, it can be possible that the values of all these properties and behavior, it can be different. The properties can be different, it can be same for all the dogs, for all the objects present in the class dog. Like the number 1 dog, it can have a different breed than the second one, and then the third one, and then the fourth one. Size, they can have different sizes, but they all have sizes. Number 3, age, they all have ages. It can be different, it can be same. And the color, now it depends. Some dogs, they are come in different colors. Okay, so again, all the properties are there common in all these 4 objects, but the values of these properties, it can be different. The behavior again, they all eat, they all sleep, run, and bark, but the way they do it, it can be different. Like the dog number 1, it can prefer some things different to eat than the dog number 2, and so on. In the same way, sleep, they can have a different way to sleep and different time frame to sleep, and so on. Alright, so let us see the difference between OOPS and POP, which is procedure oriented programming. The basic difference are as follows. Number 1, OOP is a bottom up approach, whereas POP is a top down approach. It means in OOPS we start with the object and then with the programming, whereas in POP we directly begin with the programming. Second one, we divide a program into objects in OOP, whereas in POP we divide it into functions. Number 3, in OOPS we have access modifiers such as private, protected, and public, whereas in POP it is not there. Number 4, in OOP, objects can move and communicate with each other through member functions. On the other hand, in POP, the data, it moves freely without any security, and which leads to our next point, that OOPs is more secure than procedure-oriented programming, and OOPs provide us with many more functions like overloading and inheritance, which is a main part of OOPs concept, which we will study now. So OOPs concept is based on 4 principles: inheritance, polymorphism, abstraction, and encapsulation. Yes, these are the 4 building blocks of OOPs, or you can say the principle on which this concept is based on. Number 1, inheritance. Inheritance is the property of an object to acquire all the properties and behavior of its parent's objects while acquiring its own. It is an is-a relationship, also known as a parent-child relationship. For example, we have a class animal, and we have these mammals, reptiles, amphibians, and birds. These are the subclasses. We can say that mammal is an animal, reptile is an animal, amphibian is an animal, and bird is an animal. So it is a relationship. We can also call it a parent-child relationship. The animal, it can also be said as superclass, and the mammals, reptile, amphibians, and birds are also be said as derived or child classes. So the next point is polymorphism. The polymorphism is a property of an object which allows it to take multiple forms. Yes, it means a function which can perform more than one kind of work. Now there are 2 types of polymorphism: compile time and runtime. So first have a look at the compile time. Now there are 2 types of polymorphism. Number 1 is compile time, also known as static polymorphism, and it is implemented in Java programming by the name of overloading. Yes, that means they're using the same function for more than one purpose, but with different signatures, arguments. Whereas on the other hand, we have our dynamic or runtime polymorphism, also known as dynamic polymorphism, and it is implemented as overriding. That is, we override the definition of the functions during the runtime. Well, that is not in the syllabus right now, so we will discuss this afterwards. So now let's move on to our next topic, which is abstraction. Abstraction, by the definition, it says it is to represent the essential features of a system without knowing the background details. So basically it is a way using which we only represent the details which are required and hide away all the complexity from the user. For example, let's say we have a television. We all have television at home. So what are the important features of the television which you access on daily basis? Yes, you need the power button. You need the remote control to change the channels and for pretty much all the work you do on the television, and the screen on which you see everything, and yes, the ports on which or in which we plug in the cables and dish and so on. So these are the essential features: the screen, the ports, the power button, and the remote, which is required to view television. Now, hiding away all the complexity from us, that is the speakers, the circuit board, the power supply, the ICs, the board, and everything is hidden from our view as well as from our access. This act of representing the essential features is known as abstraction. Now the next topic is encapsulation. Encapsulation simply means as per the definition, the wrapping up of data and function in a unit to keep it safe from outside interference and misuse. Now let's break down the definition. Wrapping up of data and function. So data are the properties which we have discussed earlier, and the functions are the behavior. Now data is that part, the essential features, and the behavior is the complexity which is hidden from our access. Now encapsulation, it combines both of these two things together to form a single unit, which is pretty much required in order to make that system complete and to work. And not only that, it also helps it to keep it safe from unauthorized access and misuse, as it uses the access specifiers. So the act or the wrapping up of data and function in a unit is known as encapsulation. Let again take the example of television. So in that case, the complexity, which were the circuits, the power supply, the board and everything, it is combined with the essential features, that is the screen, the ports, the power button and the remote control. So both the complexity, which is the behavior, as well as the essential features, which are the properties, they are combined together in a unit to make it work, as well as to keep the complexity safe from normal access or from unauthorized access. Only the person with the right access can use or can access those features. So that was all about encapsulation.